All right, here we go. All right, so it is, let me find it again. 0.1, oops, not there. 0.1 minus 0.1 to the third divided by 3 factorial. So it is 0.09983, and I'm going to leave a bunch of decimal places, okay? Come on. 0.9, I missed a 0, didn't I? 0.998, did I miss a 0 in there? Yeah, it's 0.0. 0.09883, is it repeating kind of? Okay, so now I'm going to actually calculate the error of how good an estimate that is. Okay, so the way that I do that is I'm going to use this formula that we've got. Okay, so I am going to, so I'm squeezing out so I can see that formula. So I need the absolute value of the remainder of the third degree. Okay, I know that's less than or equal to the absolute value of the maximum of the function. Okay, so what is, this is a sine function. What's the biggest a sine function can get? 1. So I'm putting in the max right here, 1. Okay, so this right here was my max. Okay, and then I'm going to multiply by the x minus c. So it's a Maclaurin polynomial. So what's my c value or my center on a Maclaurin? What do we remember from last week? Maclaurins are special. What's their c? 0. Yeah, so c is always equal to 0. So I'm going to multiply by the value we're estimating minus 0. So the value we're estimating is 0.1 minus 0. And then I'm going to raise that to the n plus 1 power, so which would be 3 plus 1. And then that's all going to be over 3 plus 1 factorial. Or I can think of this like 1 times 0.1 to the 4th over 4 factorial. All right, we're going to put that in our calculators, okay? So let's put that in, okay, and see what we get. So we've got the absolute value of 1 times, I'm going to probably put parentheses, 1 times 0.01 to the 4th. You guys, are we listening? We should be putting this in. Oh boy, look at that. That is tiny. Yes, it's in scientific notation. It's so tiny. Oh wait, I got a 0 in there that I shouldn't. That's better. It's still small. Not as tiny though. Yeah. Still negative, yeah. All right, so I'm going to write that out. 0.0000. Those 6 zeros. 1, 2, 3, 4, 5. No, 5 zeros. Okay. All right, so 0.0, 1, 2, 3, 4, 5, and it was like 4, like that, right? Something like that. So that is how much error we get with that particular polynomial, okay? All right, so that's it. That's all we're going to do, is just calculate the error, okay? All right, so we're going to try this again in example 2, okay? They're asking me to do something slightly different. So I want you to read example 2, okay? Okay. This time, they're asking me to find a range of possible values. So they want an inequality that's going to estimate what E is, what's surrounding E, okay? We're supposed to be finding 2 things, okay? So first thing we're supposed to find is the third degree Taylor polynomial for e to the x at x equals 1 centered at 0. Okay, so is it really a Taylor if I'm centered at 0? No, that's a Maclaurin, right? Use Taylor's inequality to find the range of possibilities for e to the x at x equals 1. Okay, so I am going to start by cranking through, and so this is the second thing we got to do, right? So there's actually two things. So we're practicing what we did last week once, okay? And then we're going to use that to determine how good that polynomial is, okay? Or how good that estimate at 1 is. All right, so first thing I'm going to do is I'm going to come over to the side and I'm going to do my calculating. Okay, so I've got the function and its derivative. Okay, and then I'm going to plug in what it is centered at. So centered at 0. So what's my original function here? E to the x. All right, and that's original f. What degree do they want me to go to? Third. So I gotta take 3 derivatives. So f prime, f double prime, f triple prime. All right, what's the derivative of e to the x? Oh, gee, we're gonna have that a few times. Okay. All right, I gotta put in 0. So what's e to the 0? 1. So all of these are 1s, right? So all of my coefficients are 1s. Okay. So my Taylor polynomial or my Maclaurin polynomial centered at 0 for e to the x, or my polynomial sub 3, right? Equals. All right, I start with my first evaluation of my original, right? So I start with 1. I'm going to add that to, I use this as the coefficient. I divide by 1 factorial, and I go x to the first, right? Because my c is 0. Plus, what's my next coefficient? Also 1. What am I going to divide by this time, though? 2 factorial x to the 2. Good. Plus, what's my next coefficient? 1 divided by what? 3 factorial x to the third. What we actually just did, you guys, that's another one of our designer series that we usually memorize. Okay? You don't have to memorize it. You can do it real fast. But if you have it memorized, it's a lot easier to work with. Okay? All right. Do I really need this mess here in front? Let's go one line of simplifying. Okay? So I'm going to go 1 plus x plus, let's see, what's 2 factorial? 2. Okay, and then what's 3 factorial? 6. So there's my actual polynomial. Okay? Now, it wanted me to do something with that polynomial. What did it want me to plug into that polynomial? Yeah, I got to plug a 1 in. So I'm using that polynomial to estimate the value at 1. Okay? So it'll be 1 plus 1 plus, let's see, 1 squared is 1, so 1/2. 1 cubed is 1, so 1/6. Okay, I am going to go ahead and do this by hand. 16/6. Okay, so we've got 1, it would be 6 over 6, right? What would 1/2 be? 3/6 plus 1/6. All right, so is Ryan right? Is it 16/6? Yeah. What's 16/6 reduced to? Divide by 2. 8/3 maybe? Everybody go with 8/3? Okay. So that's the estimate our polynomial gets us. Let's see how good it is, okay? And then see if we can get a range of values. Okay? That's our next goal, our range of values for E. Okay? All right, so now I'm applying my Lagrange remainder or error theorem. So we're doing 3 at 3. Oops. That's supposed to be an X. Okay, so I start with my maximum value. Okay. So I need to figure out my max for e to the x, but what are we evaluating it at? E to the first. So I really need the max for e to the first power, right? Or just e. What is e? Do we remember the number? It's 2.718. Okay, so something like that. Friday is E-Day, you guys. Maybe we can't forget. I always forget. All right, so we're going to put in 2. So if I think about that, let's make this prettier than that. If I rounded that, what would it round to? 3. So I know I'm never going to get bigger than 3. I'm just going to use 3. Okay? So 3. And then I've got to do the value we're evaluating at. So what value are we plugging in? 1. I got to subtract my C value. What was the C value or the center? 0. And then I've got to go to this plus 1, right? So I would do 3 plus 1 and then over 3 plus 1 factorial. All right, so what is 1 minus 0? 1. All right, what is 1 to the 4th? 1 times 3 is 3. Let's see, 4, 3, 2, 1. Look at that. Can't the 3's cancel? So don't I get 1/8? So my remainder or my error is 1/8. Okay. Now, that's not what the question was asking us. It wanted me to find a range of possible values for e to the x. So if this is what I think this is at 1, I need to add and subtract this guy to get a range of possible values. Okay? So what we're going to say is that e is between 8/3 minus 1/8 or 8/3 plus 1/8. Okay, I want you guys to put those numbers into your calculator. Now that we've done that far, use your calculator, get the decimal point, see if it makes sense. See if we did good. Okay, this is what I ended up getting. So 2.54166 and 2.79166. Do we agree?
Yeah, I got that.
Did you actually? Should I look at your computer screen?
No,
I can do that. All right. Is 2.718 the actual value in between those two?
Yes.
Yeah, so it didn't do a bad job, right? It got us a good range. We had a good estimate of it. Okay. All right. Here's where you're going to go to the loose pages. Okay. So we're going to grab this example 3. We're going to get rid of the other example 3 that was in there. I actually did next year's class a favor. I actually went and edited this in the notebook, so they don't have to add in extra pages next year. I know you guys do. I'm sorry. Okay. Let's talk about the degree of the... So it says, determine the degree of the Maclaurin polynomial required for the error in the approximation of the value of cosine of 3 to be less than 0.001 according to Taylor's theorem. Okay. So, we're going to force the error to be something. Is what we're going to try to do this time. Okay? All right. So, let's start putting it into the formula. Okay? So, I'm starting with my remainder theorem. Do I know what the degree is this time? No, that's what we're trying to find, right? So I'm just going to use an n for the degree for now. Okay? All right. What's my function? Cosine. What's the max a cosine can be? 1. So that's the max, right? My max is 1, so I'm going to leave it as a 1. Okay. Then I've got to do the value I'm evaluating. So what's the value I'm evaluating at? What's it say? 3. Then I need my C. If it's a Maclaurin, what's the C value? 0. So 0. Okay. I do not know. I know there's got to be n plus 1 factorial and then to the n plus 1. I do not know what those are. Okay. But I do know that it has to be less than this number right here. Let's think about that number for a minute. Could I write it as a fraction?
Yes.
It would be 1 over what? Yeah, good, 1,000. Perfect. Okay, so let's simplify that a little bit. See if I can use that to do some to figure out the n values. Okay, or at least to play with the n values a little bit. All right, so I'm going to start by saying I have 3 to the n plus 1 over n plus 1 factorial, right? Less than 1 over 1,000. Okay, I am going to basically cross multiply. I'm taking the 1,000 and multiplying it on the left and taking the n plus 1 factorial and multiplying on the right. So I get something like this. 1,000 times 3 to the n plus 1 less than n plus 1 factorial. Okay, I want to get my n's all on the same side. So how do I get this n to the other side? Right now it's under multiply, so how do I get it to the other side? Divide it. Okay, so I'm going to divide it over. While I'm dividing over, I tend to like my variables on the left side, so watch what I do. I do n plus 1 factorial divided by 3 to the n plus 1. The alligator has to eat the n plus 1 factorial. So I'm keeping the alligator facing the correct direction. I just moved the sides. Okay. So now I need to figure out what n value I need to be at. Okay. So I'm just going to, start plugging this into my Desmos. Okay. So I'm going to start with, I'm going to make a guess that n is equal to, let's say 7, which means that n plus 1 is equal to 8. And we're going to see what value that comes out to be. There really isn't a good way to solve it other than kind of guessing and checking with our calculator. We could. Let's try that. Let's see. Let's see if we can do that. All right, so n plus 1 factorial. Oh, sorry, let's not do n. Let's do x. Let's see if what Ryan wants to do works. Divided by 3 to the x plus 1. Oop, that makes sure it's all in the exponent. So parentheses x plus 1. Okay? And so that's what f of x equals that, right? All right. Now I'm going to do y equals 1,000. I can't exactly see that, right? So I'm going to have to do some zooming or some graph settings. I'd probably move my y-axis to like 1,300. All right, and I don't know what that, oh, look, there it is right there. Let's see if it worked. Oh, that's perfect. Sort of. Sort of. All right, so I'm going to go with both methods here. Okay, so what Ryan say work? But I can't use 11. Why can't I use 11? It's too small. It's bigger than 11, right? It has to be something bigger. So what do you think the n actually, or the x n actually is? It's probably 12, okay? So the other thing I could do is I could just start putting my x in there and seeing. So if I put in a 7, it's way too small, right? I could guess 11, still way too small, not at 1,000, right? I could guess 13, way too big. If I go to 12, am I there? Yeah, it has to be somewhere between 11 and 12, and we're going to go with whole numbers, okay? So we're getting the 12 for sure, okay? All right, so we're going to go, because we did it with the calculator, that n is equal to 12. Okay, that was a slightly different type of problem, right? Sometimes they ask them that way. Example 4, different again. Okay, so I want you to take a minute and read through example 4 for me. Oh, it should say e to the x. Okay. All they want me to do is estimate the error, right? Okay. So they're telling me, it's just the way that we get I think the tricky part on this one is the max value. Okay. What is the degree that we're looking at here? 4. Okay, so we're doing a 4th degree. So we have, we're going to set it up, the absolute value of r sub 4 of x is less than or equal to, I need the max value, and that's the tricky part, okay? What's our function? It's e to the x, isn't it? Okay. So last time we had an e, we just plugged a 1 in for it, right? Do we have 1 this time? What's the biggest number that can be in our domain? Yeah, so it'd be e to the 0.75, whatever that number is, okay? And then I have to estimate, it's telling us that this is the highest domain. So we're going to use, it wants us to go the smallest possible for the upper bound of the error. So we're going to assume we're going to plug that number in. Okay. Minus, did they give us a C value? They did not give us a C value. So we're going to use what? 0. It's a Maclaurin. Okay. And then it would be to the, it was 4. So what would my exponent actually be? 5. And then my denominator would be?
6.
Nope. 5 factorial. They match. Okay. All right. I want you guys to go ahead and plug that in. Okay. And tell me what you get. Okay. So take a minute and everybody try to plug it in. You remember, I can't help you plug it in when it comes time for the calculator. Okay. I got a really big number. Did you guys get a really big number for an error? It should be a small number. Something didn't go wrong, or didn't go right. Something went wrong. Last year, I think I was supposed to have a C value on there and do it Taylor. That's probably what happened. Okay. So, there's a typo in there, okay? It should have been said somewhere in here centered, because I'm looking at what I did last year, centered at x equals 1, or at c equals 1. All right, so how is that going to change this? What number would I have to change in here? The 0, yeah, so that's going to become a 1. All right, let's fix that in the calculation. Let me find the right one. This one? Okay. Oh, I know why. Look at why I got I didn't even type the right thing. E to the 75, e to the 0.75, yeah. I typed something terrible. I don't know what I typed there. It should have been 0.75. We're now switching it to 1. And then this whole thing goes to the 5th power. But I also have to put it in absolute values, which I did not do. There we go. So 0.00001. I think I just typed something wrong. I think our 0 would have probably been fine. Yeah, our 0 was fine from before. All right. So write that number down. I just typed it bad last time, so 0.0000, what was it? 1. My screen's frozen? It's great. There we go. Thank you. You see it on the one that's shooting out to your screen, though, right? Just the big screen's frozen. Okay. So those are a couple of different approaches that we've seen. There's one, the way that they present it in Delta Math is a little bit different, and what you have to type in is a little bit different, so I want to make sure we hit that quickly, though, because this has gone a lot longer than normal. All right, so let's take a look at a Delta Math problem, okay? These are actually not too bad. They're pretty fast, okay? We literally have to do like the one quick calculation, but they don't want us to do it. They want us to leave it in fractions and stuff, so. Okay, so on example 5, they gave us the degree 3 Taylor polynomial, so do I need to do any calculating on that? Where is it centered? 0, says right there, so it's actually a Maclaurin, okay? They gave us information about the 4th degree. This is the graph of the 4th degree, okay? So this is the 4th derivatives graph, okay? And then they want us to find, they're just using different notation. They want us to find the Lagrange error bound for an upper bound on the polynomial minus the function, and then they're doing this at what x value? 2. They're telling us what they're plugging in right there, okay? So the way we do this is we're just going to use our formula here, okay? So the remainder, right, that we've been using all along, so r sub, and this would be on the 3rd degree, right, of x. Okay, this is the one part is less than or equal to the absolute value. Okay, so what is the x value that we're looking at? -2. Okay, so we're right in here somewhere. Okay, we know that we're going to be in this kind of area right here. Okay, what is the highest or the lowest that we're getting on this graph? So we know it's never going to be above or below -8. But that could be, but we want the absolute value of that. So instead of using -8, I'm going to use +8 because it's in absolute values here. I could leave the negative and take the absolute values off, but we're going to go +8, okay? Because that's the biggest or lowest it can be, okay? All right, then we're going to do we're going to figure out what's the x value we're actually calculating at. Help me out. What's the x value we're actually calculating at or estimating? -2. Minus our c value. What's our c value? 0. To the, I have to do what to this guy? Add 1 to the 4th divided by 4 factorial. And then this is what they want typed into Delta Math. Okay? So they want, oh, they did their absolute values in a weird place. They put them, they kept the 8. Then they did... They put the -2 in absolute values to the 4th power. That's kind of weird. That's how they typed their answer in Delta Math. So they didn't do it all the way. Okay, I don't know if you put parentheses. I didn't try it. If you put parentheses around there instead of the absolute values, or if you did the actual number, if it would give it to you. Okay. All right, all it is about plugging the right things into the formula. Okay, real quick, let's look at the next one, example 6. There's 3 different types here, and I want to make sure that you've at least seen a couple of them, okay? All right. It's no different, right? Did they give it? They gave us the polynomial, right? Okay. So what is the maximum value of this polynomial? What does it tell us here? 10, right? What value are they wanting me to evaluate at? Or what degree, sorry. Degree 5, so remainder 5, okay, less than or equal to my max value is 10, right? What are they actually wanting us to evaluate at, which number? -4.5 minus, okay, what was my center? -5, so it was an actual Taylor this time. And then to the, what number? 6 over 6 factorial, okay? Then this would be something like 10. They moved their absolute value in. It would be, what, 0.5 to the 6th power over 6 factorial. Making sense? Okay. The last one, I'm not going to... Do you want me to do the last one real quick or no? Okay, the last one's the same thing, but it's a table. Okay, your max value is going to be... Okay.